So here's an example of a 3D moment. I have this force acting over at point B here, and that force is defined by 600, 300, negative 600 newtons. Okay? And I want to find the moment of that force about point A. Okay? So the equation for such a moment is R cross F. So I need to find R from point A to point B, which is given by this, which would be 0.2 in the x direction. So I move over 0.2 from this axis right here. Okay, do that in the I direction, and in the j direction I move this 1.2 down. So I move 0.2 in the x, 1.2 in the y to go from A to B, and 0 in the z. These are on the same kind of plane, xy type plane. Okay, so I just move in the x and y direction, 0.2 and 1.2. Now, cross product is simply that R cross this F, which I can plug in to that determinant where I'm taking I times 1.2 times negative 600 minus 0 minus J times 0.2 times negative 600 minus 0 plus K, which is going to be 0.2 times 300 minus 1.2 times 600. Whoops. And therefore the moment in the I direction is going to be negative 720, and again that's 0.2 times, 1.2 times negative 600. In the j direction I get plus 120 because it's minus j of the 0.2 times 600. So it's negative negative gives me the positive. Again, minus the 0 times 600. Okay, and then the k will be the 0.2 times 300 minus 1.2 times 600 times the k, which will give me that very large negative 660. And I could find the magnitude of this by taking the square root of the sum of the squares. It's a vector, just like all other vectors we've dealt with. We could deal with it in just the same way. Remember, this is a rotational vector. So if I take my right hand and I point my thumb in the direction given by this vector, it will rotate about that axis, which is really hard to visualize, but that's actually what's going on. It's creating this rotation about that axis that my right hand thumb would point in this direction, given a magnitude of square root of the sum of the squares.